Hello friends, today we've created a home automation circuit that allows us to control all the lights in the studio using mobile Bluetooth. Don't forget to subscribe if you enjoy smart DIY tech like this. We used an Arduino Nano to build this circuit and it works just like Alexa. If you want, you can even integrate a voice control sensor to control the circuit with your voice. To make this, I've used several components. It's crucial to use very high quality components for this. I've designed a PCB for an automation circuit with the help of a website, and the quality of these PCBs is exceptionally good. You can't even find this quality in the offline market. If you'd like to get PCBs designed like this, leave a comment and I'll bring you a full tutorial on the top websites for ordering PCBs in my next video. Here's a list of the components used. Arduino Nano, HC05 Bluetooth module, 5V relay BC547, transistor, 1 PCB mount, 4007 diode, 220 ohm 1/4 watt resistor, header pins, Arduino pins. All these components have properly been assembled and connected. To assemble the circuit, we used 4 PCB mounts to securely hold the circuit board in place. For switching operations, I installed 4 relay modules. These relays can be easily placed by following the printed layout on the PCB. In addition to the relays, I added 4 diodes to the circuit. These diodes are easily available online or at any electronics component store. I also included 4 transistors here, which play a key role in controlling the current flow within the circuit. Furthermore, I installed 4 resistors to ensure proper voltage regulation and protection for sensitive components. All of these components were carefully selected and systematically assembled on the PCB. The entire assembly process is quite simple if you follow the layout correctly. However, if you face any difficulties or have any questions while assembling the circuit, feel free to ask me in the comments. Now we'll quickly complete the soldering work with a proper finish. The soldering is now done neatly and the circuit is completely ready. After that, we took a Bluetooth module out, which will help us control the system. All the necessary components have now been properly assembled and connected. As part of the setup, we've included one VGA cable. Additionally, an OTGA on-the-go cable has been used to establish a connection between the smartphone and the Arduino Nano. This OTG connection is essential as it allows us to install the required software directly into the Arduino Nano. After connecting the phone to the Arduino Nano, we begin the software uploading process. Once the software is successfully uploaded, making the circuit fully operational and functional. For testing, I connected the circuit with a VGA cable. An indicator light on the circuit turned on, confirming that power is reaching the board. Next, I installed a Bluetooth control application on my phone. This app will allow me to wirelessly control the Arduino via Bluetooth communication. Now I've moved on to the important part, setting up the buttons and testing the system. I'm currently configuring each button individually so that I can customize the setup according to my needs. This means assigning each button to a specific relay, basically deciding which button will control which relay. The process is actually quite simple but needs to be done carefully to ensure everything works correctly without errors. Once the button configuration is complete, I move to the testing phase. To test the system, I've placed a small mic close to the relays. Whenever I trigger a button and the connected relay activates, I hear a sound similar to the tick-tock noise relays usually make when they switch, and the circuit is responding perfectly. So in this way, I'm able to verify that the entire setup is functioning as expected. We've now connected this circuit to the main electrical board, which means we can control all our appliances from our phone. That's the core function of this circuit. You can connect any electrical appliance to it, like fans, LED lights, TVs, refrigerators, etc., and control them wirelessly. I've personally connected all the appliances in my studio to this circuit, so I don't have to constantly turn switches on and off. I've shown how to build this circuit in a practical way, so please subscribe to the channel. That's all for today's video, friends. See you in the next one. Till then, bye-bye. Take care.